Okay. The next one, which is going to have less mistakes, is about integration, using our new ideas. So again, if you want to press pause, you can write these out, or use your booklet to print them out, whatever is easiest. So the first one, we're going to integrate something like this. So the first thing we have to do is I'm going to separate the fraction up. So I'm going to rewrite it as 5x over 2x squared minus 3x cubed over 2x squared. I'm going to simplify each term. So I get 5 over 2x minus 3x over 2. Okay, now just to make that a bit easier so you can see what I want to do, I'm going to write that first one as 5 over 2x to the minus 1, take away 3 over 2x dx. Yeah, so just simplify it. Okay, then to integrate it, well, 5 over 2, I can just ignore that and integrate x to the minus 1. Well, x to the minus 1 is 1 over x. And if I think what differentiates to give me 1 over x now, must be ln x. So ln x, and I'm just going to times it by 5 over 2 in front. Now that's an old one, so I can add 1 to the power and then divide by the new power. So 3 over 2 divided by 2 with plus c. So I get 5 over 2 ln x minus 3 over 4 x squared plus c. Good, no mistakes on that one. The next one, again, if you want to pause it so you can write it out. Okay, so find the curve. Curve passes through the point 1, 3, and its gradient is dy by dx is 3ex minus 1, and we want the equation of the curve. Well, if I've got dy by dx to get y, I'm just going to go backwards. I'm just going to integrate the gradient function. So I'm going to integrate 3ex minus 1 dx. Now, I can ignore the 3 for the second and integrate e to the x. So what differentiates to give e to the x? It's just e to the x. So then I'm going to put 3 back in front, multiplied by 3, minus 1 integrates to minus x, and I need a plus e. But this time, we've got coordinates to help us work out what the c is. So if I sub in x is minus 1 and y is 3, we get 3 equals 3e to the minus 1, minus 1, so plus 1 plus c. So c is, take with a 1, so that gives me 2. So 2 minus 3e to the minus 1. So therefore, y is 3ex minus x plus 2, take away 3e minus 1. Okay, and the last bit, again, if you want to pause it so you can write it out. So we're finding the area between the curve y equals sine x and the lines 0 and x equals pi over 3. So if we just think about what sine x looks like, pi over 3 somewhere about here. So that's the area we're trying to work out. So to find areas, we know we integrate. So we're going to integrate sine x dx between 0 and pi over 3. Now, whenever we differentiate or integrate with trig, we need to be in radians. So that's why the question's put in radians for us. So what differentiates to give us sine x? Well, I know if I differentiate cos x, we get minus sine x. So therefore, if I differentiate minus cos x, I'll get minus sine x, so positive sine x. So if I integrate sine x, I get minus cos x. So minus cos x, stick that in brackets, between 0 and pi over 3. we sub in the pi over 3 first. So minus cos pi over 3. Take away, sub the bottom one, minus cos of 0. Okay, pi over 3, that's 60 degrees, so that's just a half. So I get minus a half, minus cos 0, that's just 1. So minus 1. So it's 1, take away half. So that just gives me a half. Now again, I haven't been in the best form this morning. Let's check on a calculator, make sure I'm in radians. So options, calc, integrate sine x between 0 and pi over 3. A half. Good.